Okay, so let's talk more about quadratic equations. We're going to look at something called the discriminant. And if we have a quadratic equation, what we call standard form, this ax squared plus bx plus c equal to 0, the discriminant is defined to be b squared minus 4ac. We use the Greek letter delta, this triangle, to signify discriminant. Now, that hopefully looks familiar to you, because we should know the quadratic formula. And hopefully you're saying, oh, that's the thing under this radical. And the discriminant tells us what kind of solutions we have. It doesn't tell us what the solutions are. It tells us what kind they are. And it could be one of three things. Either the quadratic could have no real solutions, and that's if this stuff under here is negative, so it's square rooting a negative number, no real solution, it's not a real number. If the discriminant equals 0, then we have the square root of 0, so plus or minus 0 is plus 0 minus 0, doesn't matter, it's the same thing. So we have one solution, we call it a repeated root. That's going to come from a quadratic that would be factorable into something like x minus 2 squared. Here we technically have two factors, and we get x equals 2 or x equals 2. Two roots, they just happen to be the same. For a quadratic like this, in standard form, it's x squared minus 4x plus 4. If we found the discriminant, it would be 0. We have two roots, but they're both the same, so we say there's one real repeated root. And if the discriminant is greater than 0, we see this a lot, we get two distinct real solutions, two distinct real roots, meaning that they're different values and they're real numbers. There are two of them. So, here's one thing we can do with it. Find a value for m such that this quadratic has 0 real roots. Okay, 0 real roots. That's not telling me to find the solutions. It's telling me what kind of solutions I'm going to have. So 0 real roots tells me to look at the discriminant, and when that discriminant is less than 0. Okay, so discriminant, that's b squared minus 4ac. What's b? Well, b is 2m minus 1. That's squared minus 4 times a, which is m, times c, which is 1. We want that less than 0. Okay, so we need to solve this. We're going to expand. So the quadratic we're solving is 4m squared minus 8m plus 1 less than 0. Now, this quadratic is not factorable. We need to either use the quadratic formula or complete the square. And to simplify my life, I'm going to treat this as equal to for the time being. We'll deal with the less than later. So I'm going to complete the square because I'm noticing the middle term is even after I factor out the 4. So what's my magic number? My magic number is 1, so I also have to subtract 4. So we have 4 times m minus 1 quantity squared minus 3 equals 0. Okay, so now we start solving. M minus 1 quantity squared equals 3/4. And then we have m minus 1 equals plus or minus square root of 3/2. We add 1 to both sides, and we get that m is equal to 1 plus the square root of 3/2, or m equals 1 minus the square root of 3/2. Now let's stop and think about what these numbers mean. If m were to equal these two values, we would have exactly one repeated root. In other words, the vertex of the parabola would be on the x-axis. I want 0 real roots. So I need this quadratic to be, let's go back to this now, we need it less than 0. These are where it equals 0. So if we think about a number line, here's our two zeros. We have 1 minus the square root of 3 over 2. This is 1 plus the square root of 3 over 2. And this quadratic opens upward because the leading coefficient is 1. So it looks something like this. Where is that quadratic less than 0? Well, everything in between. So our solution to this problem would be any m value that is between 1 plus the square root of 3 over 2 and 1 minus the square root of 3 over 2. Any of those m values will give us 0 real solutions. The thing to separate out in your mind is that these are not solutions to the original quadratic. They are values that will give us the original quadratic so that there are no real solutions. In other words, so that parabola for this would either be completely above or completely below the x-axis, never intersecting the x-axis. That's what it graphically means to have no real solutions. Okay, so here's a big theorem, guys. For a quadratic in standard form where the coefficients are real numbers and a doesn't equal 0, if the solutions are x1 and x2, then the sum of those solutions will always be negative b over a, and the product of those solutions will always be c over a. Kind of a neat theorem. We could use this to solve quadratics with the system of equations. The two roots have to be negative b over a for the sum, c over a for the product. Let's look at that idea within this context. Without finding the solutions, I don't care what they are, for this quadratic, find 1 over x1 plus x2 and x1 squared plus x2 squared. So in other words, the sum of the reciprocals of the roots and the sum of the roots squared. Oh my. So, well, what if we had, I'm looking for x1 plus x2 or x1 times x2. Let's get a common denominator. So this would be x2 plus x1 over x1 times x2. Okay, so that theorem that we just saw says that the numerator is now opposite b over a. The denominator is c over a. Okay, that's kind of cool. So b is negative 5, c is 2, and a is 3. Now notice they're both over a, so those go away. They will cancel out when we're done here. They'll divide out. So b is negative 5, opposite of b would be 5, over c, which is 2. There we are. For the second part, x1 squared plus x2 squared, again, we want to think of this in terms of the sum of the roots or the product of the roots. Now, it might be tempting to say that that's x1 plus x2. But hopefully you're not thinking that. Hopefully you're thinking, okay, x1 plus x2, you have to FOIL. There's a middle term. It's not just x1 squared plus x2 squared. But if it was, it would be nice, right? Well, what if we subtracted 2x1, x2? Because when we FOIL this, we get x1 squared plus 2x1, x2 plus x2 squared. If I can subtract that guy from there, we're looking pretty good. Okay, x1 plus x2, that's opposite b over a, so that's 5/3 squared minus 2 times the product, so c over a 2/3, 25/9, take away 4/3, and we get 13/9. So this is where I'll leave you with this quadratic funness, if that's even a word, but this is a neat little property that you'll use periodically, not a lot, but it will definitely come in handy for some problems. So enjoy, have a wonderful time, play around, and ask questions if you got them.